Hello and welcome back. So in our previous segments we've been talking about different kinds of chemical weathering. So now what we want to do is to see what do minerals turn into when they have been chemically weathered. Now 90% of all the minerals that are on the surface and inside the earth are silicate minerals. So in the left-hand column there is the original minerals, and I've chosen silicate minerals because they represent most of the minerals that are found. And you should recognize some of those names from Bowen's reaction series when we said that you start with this magma, and then the first minerals to form is going to be olivine, and then pyroxene, and then amphibole, and then feldspar, and then quartz. So that's the order in which they form as they cool off. So now what we want to do is take these minerals and subject them to weathering, chemical weathering, and see what they turn into. So the first one is going to be quartz. So quartz turns into quartz. It doesn't change. Now some of it can dissolve as silica and then go into solution, and then it goes away in the groundwater. But most of the time quartz doesn't really change. It might get a little bit smaller in size, but it's very resistant, and it is very stable under surface pressures and temperatures, which is precisely the reason why we use glass to make jars with, so that we can store acid in them. So the quartz is not going to be affected by the acid. Okay, now let's look at feldspar. So feldspar, as you can see in its chemical formula, it's got some potassium and it's got some aluminum in it. And then when it weathers, it turns into clay. And then the other stuff that is released is going to be silica, which goes into the groundwater, and then potassium ions. Amphibole has more magnesium in it. And so again, it turns into clay, but into the groundwater goes silica and magnesium. Pyroxene has iron in it. And so what happens is that iron reacts with oxygen to make hematite. And then what goes into the groundwater is going to be the calcium and the magnesium. And then olivine also has a lot of iron in it, and it also rusts. And another kind of material that you can get is called limonite, which is, it's essentially, again, rusted minerals, but it also has a lot of water located in it. And so again, silica and some of the magnesium would go into solution, and then it is washed away in the groundwater. So the important thing is not necessarily to know all of these chemical formulas, but to know that the things that tend to survive chemical weathering at the surface is going to be quartz, clay, and then rust in some form or another. And then other stuff gets washed away in the groundwater. So that's what I want you to get out of that. All right, and so let's take a break, and when we come back, let's talk about how physical and chemical weathering can work together.